Hello, everybody. Good morning, good afternoon, good evening, depending on where you are. Welcome to today's Tech Talk, Accelerating Analytics in the Cloud with the Starburst Presto Alluxio stack. My name is Ali, and I will be your moderator for today. Before I get started and introduce our amazing panelists, just a few housekeeping items. One, we will have Q&A at the end of the session. Feel free to pop your questions into the GoToWebinar questions box. It's on your panel, and both Matt and Dipti will be answering any and all questions you have. Second, we are recording this session, so afterwards you'll get a link to both the recording and the slides for today's talk. So without further ado, I'm thrilled to introduce our two speakers. We have Matt Fuller, co-founder of Starburst Data, along with Dipti Borkar, VP of Products here at Alluxio, and they'll today be talking about how to get up and running with Starburst Presto and Alluxio. So with that, I will pass it off to Matt. Matt, please take it away.
Great, thank you. First, a bit about me. Thank you, Ali, for the introduction. My name is Matt Fuller. I'm the co-founder at Starburst. You can find my email there or LinkedIn if you wish to contact me after. Next slide. Cool. Yeah, there we go. Cool. So today we're going to be talking about Starburst and SQL anything, query anything, anywhere, along with how we accomplish that with Presto and Alluxio, and then we'll go from there. So next slide. Great. So a bit about our company first. So we were founded in 2017. Our team includes the creators of Presto and many of the largest committers, contributors, community members of Presto community. Some of us consist of former Facebook engineers, Teradata, Vertica, Netezza, and Ab Initio engineers. And we offer the enterprise Presto offering on a variety of different environments such as AWS, Azure, GCP, on-premise, and on Kubernetes. Next slide. So, before we get into Presto and Alluxio, I'm going to go over why Presto and then why Starburst, and then talk a little bit about Presto, and then finally, Dipti will talk about Alluxio, and then Alluxio plus Starburst. So why Presto? Presto is an open source project. It's a distributed query engine. It was originally developed by a team at Facebook, and who now are at Starburst, and it was solving the problem to query their data warehouse at Facebook. And one of the key pieces was this notion of separation of storage and compute, where Presto was just a query engine, and you can point it to a variety of data sources, whether it is your Hadoop data warehouse or your data lake, whether it's an S3 or GCP or Azure. You can query relational data sources such as MySQL or Postgres or Teradata, or even non-relational data sources, whether it's Kafka or Cumulo, and Cassandra and so on. And this is accomplished by just being sort of just the query engine. There's also no lock-in, so you could query Hadoop if you want, or you could query other storages such as S3 or Azure Blob Storage or Google Cloud Storage. And then finally, there's no cloud vendor lock-in either. You can run this on-premise or on sort of the major clouds. Next slide. So we've talked about Presto. We're going to talk about now why Starburst. So at Starburst, we provide the enterprise distribution of Presto. This will get you the additional features in order to deploy successfully within your enterprise environment. We have our distribution is fully tested. It's stable. It has the most up-to-date features. We offer long-term support. So if there's a security bug or some sort of flaw, we'll backport those onto the supported versions rather than forcing one to do a major upgrade. We also have a variety of enterprise-grade security features and connectors, such as role-based access control to allow sort of more finer-grained access to your data. We support data encryption, whether it's in transit or at rest. We provide ways to help you deploy and configure and run Presto at its best within your environment. We provide sort of auto-scaling and graceful scale-downs, the ability to scale up your compute to what you need Presto to query, and be able to shrink that as needed without interrupting your queries. We have a large variety of connectors to connect to the different data sources, whether it's Teradata, whether it's Oracle, whether it's S3, and so on. And then finally, from Starburst, you get 24/7 support from the Presto experts. Whether it's the hot fixes, the security patches I mentioned, and certainly access to our customer success team of data architects. Next slide. Great. So overall, this is the high-level view of the Presto architecture. Presto is a distributed system, and it's deployed on one or more machines. And so there are two roles in a Presto cluster. One role is the coordinator, and one role is the worker. Every cluster has one coordinator, or more than one coordinator if you're using Starburst Enterprise distribution with high availability, and then any number of workers. You can think of a coordinator as the brain of the system. It's making all the decisions. It's figuring out how to plan the queries, where to process them. And the worker you can think of as the muscle. This is what is doing the data processing. Now keep in mind, again, that because of the separation of storage and compute, Presto is not storing any data. It's simply querying the data. So the coordinator interacts with the data sources via what we call connectors, and you have a connector for each data source. So long as the data source in the connector can provide the data into the data model Presto expects, you can have a connector for it. So the coordinator will reach out to the data sources to get information such as statistics for use by the cost-based optimizer, table names, column types to do the semantic analysis when you run the query. It helps with the planning. And the workers reach out to the data sources to actually get the data. And sort of the details of how this is done is all encapsulated in the connector. Right? So for example, querying data from S3 requires reading the data from S3 objects from the bucket. But querying data from Teradata requires pushing some SQL queries down into Teradata. But this is all encapsulated and transparently done by the connectors, and to the end user of Presto, they just feel like they're interacting with tables, and so those details are taken care of by Presto. Next slide. So this is like a little bit more of a detail. So you can think of the API into four major categories. The Presto coordinator reaching out to get the metadata, or the statistics, or the location. Metadata being, again, the table names, column types. Data statistics being the stats of the data for use by the cost-based optimizer in order to come up with an optimal plan for better query performance. And then the location, where is the data located? For example, if it's in a Postgres database, what is that IP address of that Postgres database? And then finally, on the worker, the API to actually get the data from the source format into the format that Presto can work on. Next slide. So I alluded to the enterprise offering earlier, and really Starburst has two product offerings. We have the Starburst Presto Community Edition, and we have the Starburst Presto Enterprise Edition. The community edition is the free version of Starburst Presto that includes additional features, some in some limited ways, whereas the enterprise edition includes everything I mentioned, all the connectors, security integrations, premium, 24/7 support SLA, long-term support, and all the tooling and cloud integrations that we provide to make your deployment of Presto easier and be able to run Presto at its best. We support them on AWS, GCP, Azure, Kubernetes, and on-prem as well. Next slide. So the three kind of main categories of connector. One is the distributed storage connector, and the other two are the relational databases and non-relational data sources, and those are on the next two slides. So for the distributed storage connector, for those that you're familiar, might be already familiar with Presto, that is also called the Hive connector, but it's a bit of a misnomer to call it the Hive connector, so we like to refer to it as a distributed storage connector. And this allows you to query data that's in HDFS, S3, Google Cloud Storage, Azure Storage, or even S3 compatible storage like MinIO or Ceph. The reason why it's called the Hive connector is it queries data that uses the Hive style table format, and also it uses the Hive metastore as well to get the metadata about the files that are in these distributed storage systems. It also works with the AWS Glue data catalog as well. The key point, though, is it does not use the Hive runtime to perform the execution. Next slide. So then, it's Starburst, we have a whole list of relational databases that we can connect to as well, whether it's MySQL or Postgres, Redshift, SQL Server, Google BigQuery, Oracle, DB2, Teradata, and Snowflake. And many of these are parallel connectors, meaning one could, some of these you could write a simple connector in the open source, but for systems like Snowflake and Teradata, you really want that high performance of querying the data from those data sources via Presto, and that's what we offer at Starburst, is for those high performant connectors to those data sources. Next slide. And then finally, there's non-relational data sources. These are a little bit trickier to conceptualize because they're not always, tables, rows, and columns. But the key point is the connectors figure that out. They figure out how to take the data from these data sources and translate it into something that Presto can understand. It can be a Cumulo, Cassandra, Apache Phoenix, which is basically a SQL layer above HBase, so it allows you to query HBase, Elasticsearch, Kafka, Kudu, and MongoDB, and Redis. And I believe that's all I'm going to speak about for Presto, and I'll hand it over to Dipti to talk about Alluxio, and then go into Alluxio plus Starburst Presto.
Great, thanks, Matt. Thanks for the great introduction to Presto and Starburst. Let's jump into Alluxio and talk a little bit about what data orchestration is, where it came from, and how it kind of works underneath the covers. And then we'll talk a little bit about Presto plus Alluxio, the joint offerings that we have, particularly the joint AMI and CloudFormation template on AWS. And then we'll just walk through that as well. So let's get right to it. Alluxio actually originated from the AMP lab at Berkeley, and our co-founder, Hao Yuan, was working on his PhD thesis back then, working on Spark, streaming, and a couple of other projects, and noticed that there was a need for data to be orchestrated across many different storage systems. And that's kind of how Alluxio emerged. We've had a great year last 2019 with a lot of great momentum and a lot of different users using it both on the open source side as well as customers. So Alluxio is an open source project that it can be, you can contribute to it and download and use it. And we have the enterprise edition as well, similar in some ways to Starburst. So in terms of where Alluxio fits, typically you have the lines of businesses that leverage analytics. This could be structured data analysis, or it could be machine learning, AI type of analysis. And on the top, you might have dashboards, you might have forecasting applications, etc. Underneath that, typically you have a range of different frameworks. One of them, for example, being Presto, is used widely for querying structured data and unstructured data. And there's others like Spark, as well as Python-based frameworks that support machine learning and AI, like Caffe, TensorFlow, PyTorch, etc. Now, as Matt was talking about, increasingly we see a stack where we have a separation of storage and compute. The compute is separated from the storage and is not actually running in the same location. It might even be remote from it. And the data itself is spread across many different systems. And that's where Alluxio comes in. Alluxio is data orchestration that sits in the middle between compute and storage, and helps with many different aspects of bringing the data closer to the computes on top, making it more elastic, improving performance, as well as transformations, and I'll talk a little bit about that as well. And so it serves up the data analysts that typically work in the structured world, as well as the data scientists that are working with the more kind of machine learning and AI-based applications. Alluxio comes with a range of different APIs that sit on top that allow you to work with these different frameworks. The most popular ones tend to be the HDFS interface that allow for data that to be queried or to be accessed that's stored in HDFS, as well as to use it with any framework that uses the HDFS interface, like Presto, Spark, Flink, etc. We also have a POSIX interface, which is a file system-like interface that's used widely for the machine learning side of analytics, like the Python-based frameworks. Underneath the covers, there are also a range of other connectors, like the HDFS driver, which connects to the HDFS file system, the S3, GCP drivers as well that connect to some of these cloud object stores that are also getting very popular. And it works with any object storage like MinIO, Ceph, etc., that supports the S3 protocol. So in terms of Alluxio, when it started off, there were two kind of core capabilities it provided. One was a way to abstract away the storage, the distributed storage systems, as Matt referred to them, and created a global namespace so that applications sitting on top could view this as one big data access layer, independent of where that data was actually stored and where it was coming from, where it was being pulled in. It also includes an intelligent caching tier, which is a distributed cache that sits close to the compute and improves performance of computes like Presto, and provides a tiered mechanism to store that data and cache that data. And this is file system level data. Now, over the last couple of years, we've added more capabilities. For example, data management. Is there a way to move data from one storage system to another seamlessly for the application underneath the covers? And we've added that policy-driven data management. And more recently, we've introduced a catalog, a data catalog, a structured data catalog, as well as data transformations to make it easier for data to be consumed by the compute like Spark or Presto, and particularly with Presto, and allow for table data, so table catalogs that might be in Hive, to be accessed via Alluxio in a catalog cache, if you will, all as a part of a single system that is Alluxio. So this, in general, brings you data locality, data accessibility, so that you can bring in data, even if it's remote, from many different places into a single layer for your compute, as well as to make data elastic. So you can scale out your clusters and your computes as needed, depending on the size of your data and the type of workload. So typically, as we work with our users, we ask the question: Are you in the cloud already? Are you on-prem? Where are you in this the data journey? And there's a couple of different options where Alluxio helps. So typically, Alluxio can help in the cloud with the frameworks like Presto, Spark, and others, including the systems services like EMR, Dataproc that are run in the cloud, as well as to separate out storage and compute on-prem, or bring a hybrid approach where you're running your compute in the cloud, but your data is on-prem. So let's take a look at some of these examples of cloud caching as well as a hybrid and see how it works. So the first one is, let's assume that you're an enterprise, an organization, or a user that's running all in the cloud, and your data is typically stored in S3 or GCS or any other kind of cloud object store. You might have different computes that are running on top, for example, Starburst Presto, and you're accessing S3 for your workload. Now, typically, object stores haven't been built for analytics, and so some of the metadata operations can be slow. It might be harder to achieve SLAs. And that's where Alluxio comes in, where it basically pulls in the hot data that the compute is requesting and caches it in a layer close to the compute. And for example, if it's a Presto cluster, this would be co-located with the Presto cluster on the same instances. You use some part of the memory for Alluxio caching, and you use some part of the memory for Presto, and cache that hot data to see performance improvement. And obviously, the performance improvement, it depends on the kind of workload, the amount of data, the size of the cluster, etc. But we see improvements anywhere from 2x to 10x, depending on the kind of queries that are running. And this obviously means cutting down costs. Because when you're running in the cloud, one of the main considerations is cost. It's very easy to scale up the cluster, but it's also very expensive. And so by reducing your query times for Presto, you can improve your costs as well for your clusters. One of the examples that Starburst and Alluxio are working on together, and where Walmart recently presented a joint story, is on GCP. And so this is kind of an example of queries running in the cloud on GCP. You see a range of different options. Smaller queries perform really well. You see a nearly 2x performance improvement. You have large scan queries that see about 25% improvement. And in general, Alluxio helps with concurrency. And so the more queries that you run at a time, and if you have a concurrent workload, Alluxio can help with that and to reduce your costs as well. So in the cloud, there are obviously ways that you can build this together by pulling Presto or Starburst and then adding Alluxio to it. But we actually have now a joint offering that's available, that's Starburst plus Alluxio. So it includes the Starburst Enterprise Edition as well as the Alluxio Enterprise Edition that you can that's bundled in and is available as an AMI or a CloudFormation template. So you can create a cluster with this and scale up and down as needed. And at the end of the presentation, I'll walk you through some of the steps that can get you going using this joint AMI to improve your Presto performance. So the next use case that Alluxio helps with is when data is remote. And so when data is remote, it's typically a hybrid approach, or you might have a cloud where your bucket or S3 bucket might be remote in another region, and you want to pull data from that region. Now, because of the flexibility of the cloud, it's very easy to get compute very fast, couple of minutes, and you have compute as big or small as needed. Storage as well, S3 is provisioned very fast. But from a data set perspective, it might take time to copy that data into the cloud from wherever it is, because You might have to write an ETL job to pull the data that you need. You might have to give permissions, etc., security permissions, and that is what makes it not elastic. And so in terms of trying to have this hybrid approach where you might have data remote in a remote HDFS or in a remote object store, there are a couple of options to solve this. Typically, you could, as we talked about, copy that data on a per workload basis. And this will be it's typically done on a per analyst, per workload basis, on a daily basis, or weekly basis, and so on. It becomes quite cumbersome. You can also do a lift and shift approach that some people try to use, where they move their entire workload and the data set for it in the cloud, and they have it duplicated in two places. And while this might work well from a performance perspective, it's very expensive because you're essentially duplicating the cost. And the third option is what we call the zero copy bursting option, where you leave the data where it is, and Alluxio can pull the data, only the data that's needed, the hot data, into the cluster. So let's take a look at what that might look like. So let's say you have an on-prem cluster, HDFS cluster, that's running a range of different options. It could be running Presto Starburst as well. And typically these clusters are compute bound, they're overloaded, it's hard to scale out, they might be reaching capacity. And so if you need additional compute, the cloud is a great way to get started. Now, if you put your Starburst Presto or Presto SQL in the cloud, you will be network limited, because even if you have a large bandwidth, the amount of data, the size of data that we're talking about for some of these workloads can be very large. And so you get, the network gets, you get kind of limited by the network pretty quickly. You could copy this data over and create another data set. It creates different challenges with costs, as well as being able to merge that data back together if it's being updated. And so the Alluxio approach is to have Alluxio cluster co-located with Presto, and it pulls the data that Presto is requesting on a per block basis of the files and puts it into a cache in memory or in SSDs. It's a tiered system, and makes it available to the compute, which is Presto. And so not only do you get the benefit of increasing your compute capacity, you can leave the data where it is, and Alluxio can also sync data back. So the data is the writes that happen on the top can be synchronously or asynchronously written back down. And if there are metadata changes underneath the covers, they all are also can be propagated back and forth. There's a couple of different mechanisms to do that. I won't go into that today, into the details. In addition to that, with the Alluxio data transformation capabilities, the data management capabilities, you can actually set policies and move data from HDFS into S3 over a period of time, completely abstracted from your application. So if Presto is running on top of Alluxio, it doesn't need to know that that data has moved. Alluxio manages kind of independently and knows where this data is, and will access and pull the data from the right place. And so it helps with additional capacity, allows you to burst, as well as over time helps with a slow online migration of data to the cloud whenever you might be ready. And here's an example of again a customer that's using Starburst and Alluxio as well, where on-premise they have DBS Bank has Spark running on Alluxio, Presto running on Alluxio, and they burst into AWS for some of the machine learning workloads where they're using SageMaker, and pull data into the Alluxio cluster from their object storage on-prem as needed, and have expanded their capacity from just on-prem to the cloud as well. So that kind of gave you an idea of what the different use cases of Alluxio are. One is performance-driven in the cloud to reduce costs and improve performance of Presto queries, as well as other frameworks. It also helps with the data management, hybrid cloud approaches, where you can scale out your compute capacity as needed in another location, in another data center, or a different cloud. Now, here's a reference architecture of Alluxio. In some ways, it's similar to the coordinator worker approach that Matt talked about. So in our case, we have the Alluxio master, and you have one primary master and multiple standbys. The master actually manages the file metadata, and so this is the hot metadata. It's not all the metadata of all the storage, the files that are across all your storage systems. It's actually the hot metadata, and typically we see that it can be 5 to 10% of your total data corpus across many different systems. The master then knows which worker has those associated blocks or of those files, and the client will work with the master to pull in data into the right worker and send that data back and forth between the Presto worker and the Alluxio worker. And then the Alluxio worker can then persist that data down if there are updates into the different file systems that have been mounted and made available to Alluxio. The Alluxio worker can have data that's all in memory, so you can use RAMFS, or it can be a tiered layer, and so you can have RAM, SSD, disk, etc. On the instance that Presto worker is running. You can also have Alluxio as a standalone cluster outside of the Presto cluster, and that works as well, particularly if you have multiple Presto clusters that you want to run, that you want to optimize with a single Alluxio shared cluster. So in terms of how that data gets pulled in underneath the covers, this is kind of what it might look like. So if there is a file that's being pulled in, the first pull might be a little bit slower because it's getting pulled in from the object storage or HDFS underneath. And then from that point on, it's significantly faster. And typically with analytical workloads, you are rerunning the same query multiple times over and over again, and that's where the speed up comes in, particularly if there are some data sets that are used extensively across different workloads and different queries. You can also pin data in Alluxio, which means that it stays there and doesn't get evicted. Otherwise, you can specify algorithms that will automatically clean up the memory, evict data that's cold, and pull in data that's hot, and you can configure all of that. With zero copy bursting, it works in a similar manner. It's just that the first read is going to be a little slower because you might have the remote HDFS might be in a completely different region, different data center, but the reads from that point on will be significantly faster. Now you can also prefetch data into Alluxio. So if you know that you want to query, you want to run a dashboard on a certain hot data set using Presto, you can perform a distributed load into Alluxio, warm up the cache, and make that available to Presto so that your workload runs much faster. Typically, these tend to be workloads that are run on a seasonal or a weekly basis or a monthly basis, the Monday morning reports or the end of the month reports, where you know what data set you're using and you're running these dashboards. Obviously, for ad hoc approaches, the data will automatically get pulled in, and then the query can run on top of that. In terms of tiering, Alluxio manages the tiers as well, and so if a particular tier is out of memory, we move the data around so that room is created for the hot data, and that gets served out of memory. And then the last slide I have here is about the data management itself. We have a policy-driven data management capability which allows you to set certain policies. So for example, if data has not been used for over 90 days, it can be moved from one location to the other. You can create these policies on date access, date created, etc. And the policy interval can be set as well. It could be a couple of hours, it could be a day, and Alluxio manages the movement as well as the application changes in terms of where the data is now stored, so that Presto on top doesn't need to, there are no changes, no application changes needed when that data is moved from one location to another. So with that, actually, I do have one more slide. And so we talked a lot about caching, the caching service, as well as the data management. With our 2.1 release, we introduced a developer preview of the catalog service, which essentially allows you to attach databases from the Hive meta store that Presto uses as well, and makes these available in the Alluxio catalog. This is particularly helpful if the Hive meta store is overloaded and it cannot be, additional load can't be added for more querying, for adding new Presto clusters on top. And so what this does, it gives you additional catalog capacity as a part of the Alluxio cluster. We have built, based on the Hive connector, the Presto Hive connector, we have built an Alluxio connector that understands this catalog service underneath the covers and makes it available to Presto on the top, so that it has information about the databases, the tables underneath it, the columns in the tables, etc. And in addition to that, there is a transformation service that we have added as well that I won't go into much detail today, but there's several other resources that can help you with this. It allows you to consolidate and compact your data. One of the things that we've seen is for Presto as well as for Spark is a small file problem. A lot of these systems in HDFS, S3, have a lot of small files, and that inhibits performance. And so Alluxio, underneath the covers, can consolidate those small files into larger files and dramatically improve performance using the transformation service. So all of these together can be used with Presto. And our next release, these capabilities will be generally available as well, so that you improve the performance of your query workload even more beyond caching. So with that, let me actually show you where to find the Presto, the Starburst Presto and Alluxio AMI and CFT, and let's walk through a couple of steps to help you get started. So the first thing you can do is go to the AWS Marketplace. If you either search for Alluxio or Presto, you will see that there are a couple of different AMIs. We have, you can pick the Starburst Enterprise Presto with caching AMI that comes with Alluxio built into it. And so if you click on this, you can go ahead and subscribe to it. It's based on an hourly price, so you can take a look at what that is. Typically, depending on your instance type, it varies. And once you subscribe to it, you can. I've already done this, so it's fast. Otherwise, it might take a couple of minutes. You can continue to the configuration, which allows you to pick a fulfillment option. And what this means is that you can pick an AMI. An AMI is just a single instance. So if you want to play around with it and just try it out, you can pick the AMI. It'll be a single node. Or you can pick the CloudFormation template. The CFT comes bundled. You can pick which CFT there is. So it's the Presto with caching CFT. You can pick a region. If you're in a different region, you can pick the right one. Currently, we have only one version available, and this will be updated on a regular basis as new versions of Presto and Alluxio come up. And then you can go ahead and launch. Now, once you launch, you can configure the CFT with a range of different options. And so here I'm going to say launch CloudFormation and then click launch. And let's take a look at what are some of the things that you can configure. So the template is already ready, and it pre-populates the S3 location. So you don't have to do much here in the first step. In the next step, this is where kind of the real configuration comes in. So I'll talk about some, and then I'll ask Matt to talk about others as well. So you can obviously enter a name, VPC configurations if you have specific VPCs and the subnets. You can pick the instance type. For both Presto and Alluxio, from a production perspective, we actually recommend the or for 4 extra large. But if you want to test it out in a smaller instance, you can pick a smaller instance type, 2 extra large, etc. And then some of the, so key names, if you want to log into it, SSH into it, you can pick that. Worker count, this is how large your cluster is going to be. So basically, it is one master or one coordinator plus the number of workers. So if you say 10, this is going to create 10 workers of Presto plus Alluxio and configure each of them to use some part of memory for Presto and some part of the memory for Alluxio caching. You can pick HA, the coordinators as well. Matt, is there a recommended HA number, like a coordinator count that you recommend?
Yeah, typically 2 is good. One that allows for a hot standby of the coordinator. However, 1 is still possible, and what that means is when the coordinator comes down, it will just bring up a new one. So it really depends on one's tolerance for how long they want to wait for downtime. So having at least 1 hot standby means the failover is fast.
Great. Why don't you go through the Presto configuration and maybe talk a little bit about how each of these work?
Yeah, sure. So we can skip the one about the external access on HTTP. That's kind of a nuance. But the next ones are far more interesting. So the following ones, additional coordinator configuration URI as well as the work configuration URI, is Presto has requires a configuration, and because it's so flexible, you specify how you want it to be connected, whether it's LDAP or Kerberos, whether you want the data to be encrypted, where your SSL your certs are located, and so on. There's a lot of different kind of configurations, and we allow people to customize it by zipping up those configurations and specifying the location here. The next one, the Bootstrap Script Uri, this is essentially allows you to run an arbitrary script if you choose to do some sort of custom setup. So for example, if you want to configure Presto to talk to Datadog or something, we have customers that do that, and they're just configuring it in that script. And and over time, it might mean if we start to see common patterns, we'll add certain fields in the CFT. Scroll down a little bit, and then finally, that's just the port to connect to Presto. 8080 is default, but it could be anything. For example, if it's over TLS, it's going to be a different port, 8443, and so on. You want to talk about the Alluxio configurations?
Yeah, sure. I'll go through it, and then you can talk about the Hive one more. So for Alluxio, there's the root mount point. So the root mount point is important because essentially this is what you are creating as the root of the Alluxio file system. So the new global file system that you're using underneath your Presto cluster, which might be pulling in data from HDFS, S3, MinIO, many different locations. This is kind of the root of it. The data doesn't actually exist here, so we recommend that if you have data in HDFS or in an S3 bucket, those be mounted as nested mount points. And so this is kind of just your root directory where you might have that helps you get started, and everything else, all other nested directories, will be created under this under the Alluxio root mount point. Now, the Alluxio site properties, so if you have specific site properties that you want to enable or disable, for example, there's a write access, types of writes that you can do to the understore, you can include that here, and typically you have a key value format, so the name of the parameter equals and then the value. So that's essentially how you can add in any Alluxio properties that you want to configure with. Matt, do you want to talk about the Hive, the Metastore options?
Hey, Matt, I think you're on mute.
Thank you. Yeah, could you click the drop down so we can see the options? So for the Metastore, this is used by if you're configuring the Hive connector, and so there are a few options. There's the standalone ephemeral. So this is just like if you want to get up and running and try something right away. That's just storing the metadata in memory, and once the cluster goes away, it goes away. So it's really just to try it out for the first time. The other ones are more for production. So the other one would be connecting to the AWS Glue Data Catalog. The other one's MySQL, external MySQL RDMS and external PostgreSQL RDMS. That is if you want to, we will run a Hive Metastore and have it backed to a Postgres or MySQL database. You could choose RDS, and that means when the clusters go away, the beauty of separated storage and compute is your metadata is still stored somewhere, say it's stored in RDS. So when you bring up the cluster again, you can connect to that database and you have all your tables and everything defined to query data that's in S3. And then finally, we have the external Hive Metastore service. Like if you already have a Hive Metastore running somewhere, so you're running Hadoop in the cloud or EMR and all your tables are there, you could just connect to that over the Thrift interface.
Great.
We can skip all these fields that are just related to whichever choice you choose. So we can skip down to monitoring.
Yep.
So we will integrate with AWS CloudWatch. So there's a bunch of metrics we'll push there, such as number of queries, amount of resource you're using, whether it's memory or network, and you can see that all on a dashboard in CloudWatch, as well as any of the Presto logging is getting sent to the CloudWatch logs, so this stuff is persisted even after your cluster is gone. And then we also specify the instance profile field. So if you want to, if there's a particular IAM role that you want to use for the instance profile, you'd specify that here. This would be useful if there's a particular role to access a particular data in S3. You might create multiple clusters with different roles. If you choose to access different data, you can specify that one here. And then finally, launch Superset. Apache Superset is an open source tool that has basic functionality in terms of charts and graphs you can use. You can make really a lightweight open source BI tool, but it also has a SQL query editor, so you can connect to Presto through there and issue SQL queries to Presto. You can kind of use it right out of the box.
Great, thank you. And so once you have this cluster up and running, there's actually a tutorial, and we'll include this in the follow-up email as well, that allows you to kind of walk through the CFT, gives you some of the instructions here as well. And then allows you to explore both Alluxio as well as Presto. So you can log into it, you can SSH into it to get information, you can see the Alluxio UI, and actually try to run some queries. So we have some examples here that you can get started with. So you can create the table. There's a data set which is it's kind of a range of different flights, information about flights that you can use just as an example, and store that data in an external location in an S3 bucket, for example, and then run it with and without caching. So it gives you an idea of once you run the query with Alluxio and without Alluxio, what kind of performance differences you're seeing, and you can use this data set or you can use your own data sets. And I think, Matt, you had basically tried this out as well. Any kind of feedback or pointers to the folks listening in?
No, I mean it's pretty straightforward. If you go through the steps, it is. I would encourage people to try it if you're interested. It's pretty remarkable about the performance improvements you see once the caching kicks in. So I think it would be worthwhile trying. But there's no gotchas or anything I'm aware of.
Great. All right. I guess with that, let's open it up for questions.
Great. Yeah, thank you. It looks like we do have a few here. Just a reminder, if you do have a question, go ahead and enter that into your question box on your GoToWebinar panel. We'll get those answered. And just a quick note, I did add a link to the tutorial in the chat box for anybody that's interested in checking that out. Okay, so first question. What kind of data statistics does Presto get from Alluxio about the underlying remote table? Does Presto see the remote table schema at all? So I guess, Matt, do you want to take that one?
Yeah, so right. So the statistics we get, at least with the Presto Query Optimizer, is we're getting them from the data sources themselves. So it's sort of transparent. Like Presto doesn't know it's querying Alluxio or not. It just thinks it's querying S3 or HDFS. So the statistics it's getting are ones about the data, min-max values, average column length, counts, null counts, and so on. And those stats are used by the query optimizer to create the query plan. So there really aren't any Alluxio specific stats gathered. I don't know if you want to elaborate on that more, Dipti.
Yeah, exactly. I mean, in most cases, the table statistics typically live in the table catalog, right? And so that is either in the data source or in the Hive meta store. And that's kind of where they live and where the query optimizer is getting those from. In the catalog service that we're building, we're basically inheriting the Hive meta store database and the table and the statistics. So if over time, as the new Alluxio connector gets used, it will essentially just provide them as acquired from the Hive meta store. So Alluxio is basically the layer that's managing the data and the blocks in the file of the files themselves. And then for the metadata, it's managing the metadata of the file system. And for the table data and the table stats, which is really what any optimizer leverages, those typically will come from the Hive meta store or from the relational database that Presto is querying, which is a dependent of Alluxio.
Okay, great. Next question. How do you maintain data consistency if data is shared and modified by multiple apps in different cloud environments?
Yeah, and I think that's a question for Alluxio. So in terms of consistency, there are a couple of different models. For analytical applications, typically, the data that is being queried typically does not get overridden by the application sitting on top. So they're read-heavy workloads, for example, like a dashboard that's being run on top of Presto. And if there are writes that are happening, those writes typically create new data. So if you're running an ETL job, you're basically reading data and you're writing data, and that's typically going into a new location. And so it's very rare that the same file gets updated. Now, there are situations where that might happen. For example, if there is a particular file in HDFS that's being updated underneath the covers. In that situation, there's a couple of different approaches that Alluxio uses. The first one is we interface with iNotify, which is the HDFS protocol that sends out notifications when there are updates underneath the cover. And so when we get the notification, the metadata gets refreshed, and so you know that there has been an update underneath. The other way is a pull model where Alluxio on a certain frequency goes and pulls data from underneath the covers, the metadata, and says, is there any change that has happened? This can be done before a query is run or on a periodic basis. And so that allows you to keep the data in sync. But it's extremely rare for the same file to get updated. More often what happens is if your data is partitioned, a particular partition will have new files that have landed in because there might be a clickstream data that's basically creating new files, small files that are coming in. So it's very rare to see the same file get updated. But in those situations, we have these two mechanisms to keep the cache consistent, and if the metadata has been updated, the cache gets invalidated. Matt, do you see users doing a lot of updates on the same data, or maybe it'll be good to kind of get your perspective as well?
You can certainly do it through Presto. I'd say right now the heavy use case is definitely the read, the consumption, really using Presto for that. With that said, we are working towards adding more kind of DML capabilities in Presto, so that could change. But right now it's primarily consumption.
Yeah, and the other thing I would say is from an Alluxio perspective, this is not meant to be used in an OLTP system, right? There are a lot of other good databases and caches for those use cases, which is where you see a lot of heavy updates, inserts, updates, deletes to the same data and the same data set. It's really meant for analytical and machine learning use cases, which are read intensive, or it's generating new data and could be write intensive from that perspective.
Okay, great. Next question looks like for Matt. Does this kind of solution cache results?
Yeah, great question. The question was, does the solution cache results? The answer is no. We're actually caching data at the data source layer using Alluxio, so not on the front end of the results of Presto, right? Sometimes I think that's, I do get that question asked from time to time, but it doesn't cache results.
Okay, great. So a few minutes left. I think we have one more question here. How does security work for Presto plus Alluxio together?
Yeah, I'll answer the Alluxio question and then pass it on to Matt.
Yep.
So security, I think the question is more about auth and authorization and authentication. Typically, in a production environment, most users will have an external system like Apache Ranger or others that basically that's where they set the roles, have groups for users in terms of who's authorized to use and read and write what data. And that's kind of where I think both Presto but Alluxio plugs in, where we have the Alluxio integration with Ranger, and so you can set which users and which groups have access to which files, which folders, which mount points, and so that's kind of typically how it would work. Alluxio does have its own users and user groups. You could use that if needed. And then from typically in terms of the authentication, if the environments are Kerberized, and so you typically have a delegation token that might come in from the layer on top, gets passed down, and so that's kind of how how Alluxio works with Kerberos. There's also security is such a big area. It means many different things. These are kind of the more common things that come up. We obviously have TLS support, where the data is encrypted over the wire between workers, because there is worker-to-worker communication, as well as client-to-worker and so on. So on the wire, and then you can use client-side encryption to actually encrypt the data that's stored in Alluxio itself. Matt, Presto, on the Presto side?
Yeah, no, it's a good segue. Yeah, I'd say in terms of security for Presto and Alluxio, it works the same way as if Alluxio wasn't there. So it's sort of the beauty of the solution is it just kind of plugs in. So in terms of Presto, there's really two main parts: authorization and authentication. So you can authenticate to Presto, and there's a variety of ways we support that, whether it's LDAP or Kerberos or certificate-based, and so on. And then there's the authentication to the actual data source. So that's however we wish to authenticate to the variety of data sources. If it's a relational data source, then that's using a password, or maybe it's Kerberos. For Hadoop, it could be Kerberos, and so on. And then there's the authorization piece. That's what, once you've proven who you are and that you can access the system, it's what can you access. That's the authorization piece. And that's where we'll integrate with Ranger as well. We also integrate with other technologies like Blue Talon and Sentry, but Ranger being one of the larger uses. And that's where you can specify the policies of who can access what data, or what roles can access what data, and even fine-grained policies down to the column level. We have row level filtering, data masking, and so on. That's sort of all transparent to Alluxio. Once we get the data, we can enforce those finer grain policies on the data. So the security pieces sort of complement each other between Alluxio and Presto.
Great. Okay, so with that, I think we are actually a little bit over time. So to everyone who joined us today, we thank you for your time. We hope you learned a bunch about Starburst Presto and Alluxio. Thank you to Dipti and Matt for the amazing content and slides. And just as a reminder, if you did attend, you'll receive a link to both the recording and the slides from today. So thanks to everybody, thanks to the presenters, and we'll see you next time.
Great. Thanks, everyone. Thanks, Matt. Take care. Bye-bye.
Thank you. Bye now.
Bye.